Hello all. So this is the second lecture of programming in C. In this lecture you will see basics of computer architecture. That is where we will see what is a processor, what do you mean by this memory, then input and output devices. So these things you might have seen in school days and all. We have to study all these things also in this syllabus. So this is a basic structure of a computer. If you see, there will be some input unit where we will obtain some data, and this input unit is connected to this storage unit. So whatever we get, we can be stored. We have a primary storage and a secondary storage. So this together will form the storage unit. Then we have a central processing unit, the processor, we call it a CPU. Inside the CPU, we have a control unit and an arithmetic and logical unit. So this together is known as a central processing unit. So what we do is we'll give some input. This will be stored in primary or secondary memory, and whenever we want to perform some operation, we'll be using the central processing unit. So it will be performing all these operations. It will be getting data from this primary storage, data from this primary memory, and it will execute and it will return the output, and the final output will be given to the output unit. So we'll get some useful information. So data will be changed into some useful information. So this is the data flow arrows, and the dotted lines are known as control flow arrows. So there is some control flow bit happening here. There is some control flow. So the control unit is a person who will be doing all this control flow operations. So the control signals will be given by the control unit. So you will see each unit separately. So first we will see the input unit. So this input unit connects the external environment with internal computer system. So anything which connects the external environment will be considered as an input unit. So we have already seen different types of input unit. So what it does is it will accept the data and the instructions from the outside environment. Then what it does is it will convert it into a machine language which is understandable. The humans will be giving in different forms. So it might be input may be an image, or input may be an electric signal, electric pulse, or it might be anything. It can be anything. It can be a video, or it can be a mouse click, or it can be anything. Keyboard press, all this will be input. So it accepts those data and instructions from the outside environment, and it converts it into machine language, and it then supplies the converted data to the computer system. So this is a process how input unit works. So we have seen different input units: your keyboard, the digital camera, the digital video, graphics tablet. If you want to write something on tablet, it will be converted. Then image scanner, joystick, microphone, mouse, trackball, touchscreen, everything. All these things are input units. It can be even electric pulses. If you are taking some electric signals, all this can be considered as input unit. So something which is connected to the external environment and which we from where we get data is known as input unit. Then similarly we have output unit. The output unit connects the internal system of a computer to the external environment. So it provides the results of any computation or instructions to the outside world. So this output unit will provide the results. So it can be anything. So it can be a computer monitor, it can be a printer, it can be a speaker, a projector, sound card, video card, etc. So all these will form the output unit. So whatever information or whatever processing of this data, and we get some useful information, and this information will be passed on to the external environment. So that will be called as the output unit. Whatever maybe, it may be a printer, it may be a monitor, it can be anything. So we have completed this input unit and output unit. Next we will see the storage unit. So if we say storage unit, we have primary storage and secondary storage. So we will see each one separately. Storage unit, it holds the data in the instructions. So whatever data we will get, it will be held here in the storage unit. So it holds the data and instructions, and also it stores the intermediate results before these are sent to the output devices. So before sending it to the output device, all the intermediate results are also stored in the storage unit. So and also it stores the data for later use. So if we want to use data for, maybe there will be some intermediate computations and we need this data in future, so all those temporary data will also be stored in the storage unit. And the storage unit is divided into two categories. First one is primary and second one is secondary storage. So primary storage, it is to store the data which is being currently executed. So whatever we are currently executing, all the programs will be stored in the primary storage or primary memory. So we know that RAM, you have heard about random access memory, RAM. So RAM is a primary storage device. So whatever program, if you are playing a game, so that game will be in the whole thing, the software will be in the secondary storage or the hard disk. So when you execute it, that program will be brought it into the main memory, or we call it as the primary memory or the storage or primary storage. So or the RAM. So that program will come to the RAM and the CPU will be accessing this primary storage. So all the program, it is used to store the data which is being currently executed. So currently what all programs are executed, everything will be in the primary storage. And it is used for temporary storage of data because data is lost when the computer is switched off. So it is known as volatile memory. So data will be lost. If the power goes off, whatever that is stored in the primary memory will be lost. So if you are running some program, it won't be there. So when the power goes off, or that memory or whatever that is the memory will be reset. Nothing will be there. So random access memory is an example for this primary memory, and we will be using this RAM. We have heard about this RAM. If in your mobile phones also we have a RAM memory. Secondary storage. So it is a slower and cheaper than primary memory. So here it is used for permanent storage of data. It is known as non-volatile because it remember the things that is there in the secondary memory won't be lost when power is gone. You know that your hard disk is an example for this primary memory. Secondary storage or CD. Everything will be there. Even if the power goes off, the data will remain in the secondary storage device. So it's a permanent storage of data. That is why it is known as non-volatile memory. So this is the organization of primary memory. So we will see this primary memory and secondary memory separately. So this is the organization of primary memory. So primary memory we can divide it into two. One is random access memory and second is read-only memory, ROM. Then in RAM we have different RAM. We have DRAM, then SRAM. Then in ROM we have PROM, then EPROM, and in EPROM we have EEPROM and UVEPROM. So we will see all this primary memory separately. We will not be going to secondary storage devices, but in your assignment we will be seeing what this hard disk and all. I will mention about the assignment later. So we won't be much dealing with the secondary storage. So secondary storage, there will be hard disk which can be used to store permanent things. So we'll be going through this primary memory in detail. So we'll see random access memory first. So it is the internal memory of the CPU. It is used for storing data, program, and also program results. So it is an internal memory of the CPU. So CPU will be accessing this primary memory always, or the RAM always. So it's a read-write memory which stores data until the machine is working. So we have already seen it is a non-volatile. So we have already seen this. It is a volatile memory. So that data will be lost when power goes off. So it's a read-write memory. We can read into it, or we can write it to a memory. Read from that memory, and we can write something into that memory. So when the machine is switched off, data will be erased. So nothing will remain in the RAM when the power goes off. So access time in RAM is independent of the address. So because a RAM it is a random access memory, uh, there may be several address locations. So if you are using some 4 GB RAM, so there will be thousands of address locations. So whatever address location, even if it is the first address or the last address, it will take the same time to access data from all the address locations. So access, that is what is mentioned here. Access time is in RAM is independent of the address location. So there will be several address locations. So each memory cell will have some address location. So if you are trying to access the first address or the last address, all will have the same access time. So it is independent of the address. It is not dependent on the address. So data in the RAM can be accessed uh, randomly, but it is expensive. So this data and the RAM can be accessed randomly, but it is expensive. So random is possible. It is not sequential. Any address location can be accessed. If you want to access the in between some address location, 500 address or the 1000 address, you can access it randomly. But it is very expensive due to this. That RAM access is expensive. It is very costly. So we have two RAMs. The diagram we have seen: static RAM, SRAM, and dynamic RAM. So we have mainly static RAM and dynamic RAM. So in DRAM and all, we have different RAM types available. So SRAM was the initial RAM that was developed, static RAM. Nowadays we are using dynamic RAM, and in DRAM we have different versions. And we have SDRAM also. Later SDRAM came, that is synchronous dynamic random access memory. Then in SDRAM we have different speed: DDR1, DDR2, DDR3, like the DDR4. Also nowadays DDR4 has been developed. So all these memories, types of memories are there. So more on to this DDR type RAM and all, you have to deal in your assignment. So we'll talk about it later. So now we will see that we have two types of RAM, but that is static RAM and dynamic RAM. So we have seen this RAM. If you open your computer or if your laptop, you can see this kind of slots. So this is a RAM memory module. So we will see static RAM. So static indicates that the memory retains its contents as long as power is being supplied. So SRAM chips use a matrix of 6 transistors and no and no capacitors. And there are no capacitors are used in SRAMs. We have a matrix of 6 transistors that are aligned to the, like in a matrix format. So I'll show the diagram. So SRAM chips are actually each memory cell will be consist of 6 transistors. Okay. And here transistors, you have already studied transistors in your school days, and in your first year maybe you have studied in the electronic circuits. So transistors do not require power to prevent leakage. So that is why SRAM need not be refreshed. We need not refresh this RAM. If you consider the DRAM, we need to refresh it. In the case of SRAM, as we have only transistors in it, there won't be any leakage, power leakage won't be there. So we don't require this power to prevent this leakage. So we need not refresh it. So it consists of 6 transistors arranged in a matrix format. And SRAM uses more chips than DRAM for the same amount of storage space. So we have to use, if you want to store 1 GB SRAM, 1 gigabytes SRAM and 1 GB DRAM. So if you consider SRAM, it uses more chips. We require more chips than DRAM. So it will be much more bulkier than this DRAM. So the manufacturing cost is higher than DRAM. SRAM's cost is much higher than DRAM, and it is used as cache memory. Mainly SRAM chips were used as cache memory. So I'll talk about cache memory later. It is the fastest of all memory. Cache memory is the fastest of all memory. So it is directly accessed by the CPU. We use it as a temporary memory in between CPU and primary memory. We have a cache memory also. We will talk about it later. So SRAM, its manufacturing cost is higher. It is very fast. So it is used as cache memory also. So it consists of 6 transistors. So these are the characteristics of SRAM. It is long life, we need not refresh it, it is faster, and it is used as cache memory, and it is very large size, and it is expensive also, and high power consumption is also there. It uses more power than DRAM. Next is dynamic random access memory. So it must be continuously refreshed in order to maintain the data. So that's the problem with DRAM. We need to refresh it always. So there will be power will be needed to refresh this memory always. So DRAM is used for more system memory because it is cheap and small. So this is the thing we will use as RAM nowadays. So DRAMs are made up of memory cells. So there will be different memory cells, and these memory cells are composed of one capacitor and one transistor. So in the case of SRAM, it consists of 6 transistors and no capacitors. In the case of DRAM, we have a single capacitor and a single transistor. So these are the characteristics. It is of short data lifetime, that needs to be refreshed continuously. It is slower as compared to SRAM. When we compare to SRAM, this is much more slower than DRAM. Then it is used as RAM. It is smaller in size. So when we consider the size, it is smaller than SRAM, and it is less expensive than SRAM, and it has less power consumption than SRAM. So these are all characteristics are compared with SRAM, not with other memory. We are comparing it with SRAM, static RAM. So this will be the SRAM. This is just to show what you mean by the 6 transistor. We can see that there are 6 transistors are arranged. So this is a SRAM cell. So this is a memory cell of SRAM. So 6 transistors are arranged in a matrix-like format. And this is actually a DRAM. We have a FET transistor and a capacitor. And a capacitor here. So we have a transistor and a capacitor. So DRAM consists of a single transistor and a capacitor. Then that's all about SRAM and DRAM. And later in SRAM was the earlier thing that were used. So they were using this almost MOSFET type of TTL. Even though TTL transistors were used, MOSFET. You have heard about this MOSFET transistor. Mainly it was using this MOSFET transistors. Then DRAM came, and DRAM, they were developed by different people. So nowadays DRAM are mostly used. Then after that SDRAM came, synchronous dynamic random access memory. We have different SDR. There was RDRAM, like that. Different types of SDRAMs came. Then later on DDR came. DDR, DDR2, DDR3, like that. Then LPDDR, like that. Different RAMs, SDRAMs came. Then afterwards, for graphic and all, we have SGRAM is there, synchronous graphics random access memory. SGRAM, synchronous graphics random access memory, and also high bandwidth memory, that is HBM was there. So it was mainly used for this graphical purpose and all. We have this different SGRAMs. We have GDDR, like that. Different things are there. When you consider this graphics card and all, there are different RAMs used there. Now we will see a read-only memory. So it is a memory from which we can only read and we cannot write onto it. So this is, if you consider in your mobile also, we have ROM chip. So you'll be resetting your mobile and all. You have seen this ROM in your computer also. There is some ROM memory. So it is a memory that is used to boot the system. So this memory is actually used by the manufacturers. So they will write something onto the ROM memory, and that ROM memory will help you to boot or initially start the system. So in order to start your initial system, you need some memory or some programs that should be loaded. So all those programs will be loaded in the read-only memory. So it is a memory from which we can only read but cannot write on it. It is non-volatile. That is, power is even if the power goes off, that memory will remain there. The data inside that memory will remain. It won't be erased. So information is stored permanently. ROM stores such instructions that are required to start a computer. So this ROM chips and ROM memory are used by manufacturers. So they will be loading some code into the program. So when you switch on the system, something has to happen. What all things that should be done when you switch on your system? All those programs will be stored in the ROM memory. So this operation, starting this computer operation, is referred to as bootstrapping. So we'll see that later. Bootstrapping. We call it as bootstrap. So the bootstrap program is stored in the ROM chip, and it is also used in other electronic items like washing machine. If you take a washing machine or microwave oven and all, you can see this kind of uh, ROM chips inside it. All the programs to run that washing machine, everything is written in the ROM memory. Or if your washing machine, if you check, there will be different kinds of programs, daily wash, like that, heavy blanket. All those programs, all those code are written on the ROM memory. And even in your mobiles also, you have this ROM memory. And in ROM, earlier ROMs were known as mass ROM. First type of ROM was called as mass ROM. So it was the very first ROMs. It was hardware devices that contained pre-programmed set of data or instructions. It was inexpensive. That was cheap thing. Then came the programmable read-only memory, that is known as PROM. Programmable read-only memory. It is a read-only memory that can be modified only once by a user. So we can program it only once. We cannot change anything. So if we program something, it will remain there in the PROM memory. We can program it once. After that, we cannot change or modify that program. So user buys a blank PROM and enters the desired contents using a PROM program. So there will be a PROM program that we can be entered into the blank PROM, and this will be loaded. So if we want to make a washing machine, we will buy this PROM chip, we will write our own code, and we will program it in the PROM, and this PROM will be inserted in the washing machine. So it does all the operations based on our instructions. So inside the PROM chip, there are small fuses which are burned open during programming. So there are small fuses inside it. It will be burned open during programming. That is why we can write only once. After that, we cannot change it or modify it. So it can be programmed only once, and it is not erasable. So this memory can be programmed only once, and it is not erasable. That is known as PROM memory, programmable read-only memory. Then another type of ROM is erasable and programmable read-only memory. It is known as EPROM, erasable and programmable read-only memory. So it can be erased by exposing it to ultraviolet rays. You can call it as UV EPROM also. UV, ultraviolet EPROM. Based on ultraviolet light, if we send some ultraviolet light for a duration of up to 40 minutes, everything that is there in the chip will be erased. So we can use it again and again. So this is known as erasable and programmable read-only memory. And here during programming, what it does is an electrical charge is trapped in an insulated gate region. We have gates inside. So a charge will be trapped inside it. So you can delete it also. So charge can be retained for more than 10 years because the charge has no leakage path. So that's how this ROM works. So EEPROM works based on electrical charge, which is trapped inside an insulated gate design, and this charge will be retained for more than 10 years because there is no leakage path. So that is why something written on the ROM will remain there permanently. So for erasing this charge, we can pass this UV light is passed through a quartz crystal window. We can pass it and we can delete it. Then we have EEPROM is there, electrically erasable programmable read-only memory. Here we use ultraviolet rays. So then it is known as UV EEPROM. Then we have electrically erasable, where we use electrical signals. EEPROM is programmed and erased electrically. So it can be erased and reprogrammed about 10,000 times. We can read and write at least 10,000 times. So if we take your Raspberry Pi and all, we have the EEPROMs and all. So where you can try some code, and if it is not working, you can erase it again. You can write it like that. So both erasing and programming take up to about 4 to 10 milliseconds. So any location can be selectively erased and programmed. So that's the advantage of EEPROM. If you want to delete only some portions of the EEPROM, it is also possible. So if you want to delete this 530 location, it can be deleted by using this EEPROM. And it can be erased one byte at a time rather than erasing the entire tape. So each byte can be erased separately. So that is the advantage of EEPROM. So usually in programming, when we try some programming in hardware and all, we have EEPROMs. So if you take Raspberry Pi and all, we have EEPROMs where we burn. We call it as burning that program into that chip, and after that we'll erase that. Again we'll try to write some other program and burn it into that. So that is known as EEPROMs. So advantages of ROMs: it is non-volatile, so it is permanent. You can, even if the power goes off, nothing will happen. It cannot be accidentally changed, nothing accident changes won't happen. Then it is cheaper than RAMs, it is easy to test, then it is more reliable than RAMs, and it is static and do not require refreshing. All those refreshing activities as in RAM, there is nothing in here. It is static, that is permanent. Contents are always known and can be verified. So all the contents are known and it can be easily verified, because the manufacturer usually code everything and will be given to you. So this is all about the storage unit. So we have seen primary storage, then we have secondary storage, that is hard disk, all these things will be there. Then we have a cache memory. So there is some memory in between this primary storage and the CPU. So in between this, we can consider a cache memory will be there. So it is in between CPU and primary memory, we have cache memory. So it is actually a temporary memory which is used to store some programs that are being executed. So it is a very high speed memory. It is actually to speed up and synchronize with that high speed CPU, because CPU is running at high speed and primary memory is not running at the same speed of the CPU. So in order to cop that speed with the CPU, we use this cache memory. So this is very fast. So all the programs that are recently accessed or will be accessed, programs that will be accessed in the future, or those address locations will be stored in the cache memory. So CPU can access this cache memory and find out whether it is there in the primary memory, it easily get it. So it's like simply like a buffer between this RAM and CPU. So it holds frequently requested data. All the frequently requested data and instructions will be stored in this cache memory. So it is actually, this cache memory is to reduce the average time to access data from main memory. So it takes some time to access this data from main memory. In order to reduce that, we use this cache memory. It is smaller and faster memory. It stores data from frequently memory locations. It is actually, what it does is, whatever that things that have accessed frequently, all those memory locations will be stored in this cache memory. So CPU can simply refer this cache memory and see where that frequently accessed program is there. Then it will fetch from this primary memory. So that is why we use cache memory. So these are the different levels of memory. Level 1 or register, we will see that register later. So data is stored and accepted that are stored in the CPU. We have accumulator, program compounder, address register, we will see that later. Then level 2, we call it as cache memory. It is faster memory which has faster access time. Level 3 or memory, the computer works currently, all the programs will be run in this level 3 main memory. Then we have level 4 or secondary memory. It is the external memory which is not as fast as memory, but data stays permanently in this memory. Then we have central processing unit. So it is known as a brain of the computer. It is known as a brain of the computer. It is a control center of the computer. So all the instructions will be executed inside the central processing unit. That is why it's known as a brain of the computer. It controls the whole computer. The whole system is being controlled by the central processing unit. So what it does is, it first fetches the instructions from memory. So in order to execute something, it first fetches instructions from that primary memory or the RAM. Then it interprets the instruction. So it have to interpret. It has to understand what that instruction is. So it will interpret the instructions. Then, if required, data is fetched from memory or input device. Maybe in some instructions, if that instruction requires some more data that is to be fetched, it will fetch from memory. Or if some data is to be fetched from the input device, that is all. That will also be done by the CPU. Then after that, the CPU executes or performs the required computation. It will perform that, whether it is addition, subtraction, or multiplication, or any kind of operation. It will do that operation, and after that it stores the outputs or displays on the output device. Sometimes it will be stored in the memory, and after that it will be given to the output device, or it may be permanently stored in the secondary storage device. So we have mainly three main components which are responsible for different functions inside the CPU. One is arithmetic logic unit, second is control unit, and we have memory registers also. So these are the three things that are there inside the CPU: arithmetic logic unit, control unit, and memory registers. So arithmetic logic unit, so it actually performs a mathematical calculations and also takes logical decisions. So mathematical computations can be anything. It can be addition, subtraction, multiplication, and division. So all these four basic operations. With these four basic operations, we can perform any type of mathematical computations. Then we have logical computations happening inside this arithmetic and logical unit. It can be comparison of two data items to see which one is larger or smaller, or it can be equal to, less than, greater than, less than. Like that, there will be 6 types of operations. If we want to compare two data, where we want to see x and y, whether x is greater than y or x is equal to y, x is greater than or equal to, like that, we can add different kind of logical operations inside this. So mainly this arithmetic and logical unit performs all the mathematical computations, and also it does this logical decisions also. Then we have a control unit inside this central processing unit. So this is a thing that directs the operation of the processor. So control unit is actually the control center of the computer. So he controls everything. He gives control signals to the input device. If you want to get some data from input device, the control unit will give some control signal to the input device. Or if you want to print something, what the control unit does is, control unit sends a control signal to the printer. You print this thing. So it actually directs the operation of the processor. It directs everything. So it directs the entire computer system to carry out or execute stored program instructions. So control unit does not execute any program instructions. So inside this control unit, it does not execute any program instructions. It actually, what it does is, it just controls the execution of all other units. So it directs other ports of the program to do something. It is actually like a director. So it directs other parts of the system to do something. So if I want some input from the keyboard, it will ask the keyboard input something, or like that. Or if you want some photo to be taken, it will ask the camera to take a snap, like that. So control unit must communicate with both the arithmetic and logic unit, and also with memory, and also it may communicate with the external devices also. So how a control unit works? So it receives input information which is converted into control signals, and these control signals are sent to the central processor. That central processor, and the computer's processor then tells the attached hardware what operations to perform. This is how it does. So it receives input information which is converted to a control signal, and the control signal is sent to the central processor, and that processor will tell the hardware to do that thing. So this is how the control unit works. So the functions of control unit, so it coordinates the sequence of data movements into, out of the data, and between a processor, main subunit. So it coordinates everything. All the data movements will be coordinated. So how to processor, it will direct the processor to send this thing to that thing, to send the data to this thing. All this thing will be coordinated by the control unit. Then it also interprets its instructions then controls the data flow inside the processor. Inside the processor, there will be some data flow. So all those data flow will be controlled by the control unit, and also it receives external instructions or commands to which it converts a sequence of control signals. So it may receive some external instructions also, or it might receive some external command. What it does is it will convert it into a sequence of control signals. Then it controls many execution units like ALU, data buffers, the registers. All these things which are inside the CPU will be controlled by this control unit. And it can handle multiple tasks like fetching, decoding, execution handling, storing results. If we want to fetch some instruction, decode that instruction. We want to decode what is that there in the instruction, or execution handling is to be done if you want to execute something, or if you want to store that result. All this thing will be performed by the control unit. Then the third thing that is there inside the CPU is a memory registers. So it is actually a temporary unit of the memory of in the CPU. It is a temporary memory unit of memory in the CPU. So it is used to store the data which is directly used by the processor. Whatever the data that is being used by the processor will be stored in the registers. So whenever some instructions are there, and we give some instructions, so what the CPU does is the instructions will be divided into some different parts. The data, the address, everything will be divided. So address will be stored in some registers. The instruction or the data will be stored in some some other registers, like that. So it is used by the CPU to store the data which is directly used by the processor. So it can be of different types, sizes: 16-bit register, 32-bit register, 64-bit register, like that. There will be different sizes of register. So this is costlier. That is why there will be only lesser memory of registers. So each register inside the CPU has specific function. So there are different kinds of registers that are available, and they will be used for different functions. So if we take maybe it may be to store data, it may be store an instruction, it may be to store address of location. So maybe some registers will be store only data, some registers will be used to store only instructions, some registers will be used to store address of location. Like that, there will be registers will be used for some specific functions. Then user registers can be used by an assembly language program. So we will be seeing what is this assembly code and all. So this assembly programmer will be using these registers to store the operands, intermediate results, all these things, data, everything will be stored in registers. So when you do this assembly code, so if you write the code directly onto the assembly code, you will be using this registers. So you will know what all later in later semesters you will be learning about this hardware programming. So during that programming, you will see how to write assembly code and all. So when you use this assembly code, you will be mainly using this registers. You will be writing your code directly onto the registers. You won't be writing anything on the memory, main memory, or you won't be using any other instructions. You will be simply writing, use this registers to store this data, to add the content of this register with the content of this register, use this code. Like that, you will be coding everything directly onto the registers. Then you will be aware of which all registers are present in your system. So these are some of the registers: accumulator, address register. We have program counter register, which is used to store the next instruction. Instruction register is there, which is used to store the instructions. The memory address register, memory buffer register. Then we have different general purpose registers. Like that, there are different registers that are available for the CPU to perform different operations. So whatever you do, whatever operations, even when you are playing some game in your computer, what it does is it will be stored in the main memory. After that, CPU want to execute something, what it does is those instructions in the main memory will be converted into some assembly code, and it will be run inside these registers. Something will be stored in different registers, and the CPU will be accessing these registers to execute the whole thing. So this is speed, storage, different storage things, registers based on speed. If you take, registers are the very fast, main memory is fast, secondary is slow. Then duration, it is very short term. It is short term. While the program is active only, this main memory will be there. In secondary, it is long term. It is permanent, somewhat permanent. Then power down effect, data will be lost in registers. Here RAM also, main memory, RAM data will be lost, ROM data will be maintained. In secondary storage, everything will be maintained even if the power goes on. Then size of unit transfer, it may be bit, byte or word. Only small amount of data will be transferred in registers. But here it will be byte or word. If you consider this, it will be physical record because it will contain huge amount of data that can be transferred. Then ALU access, registers can directly access ALU. Here main memory cannot directly access, it can indirectly access that ALU. Then secondary device cannot at all access this ALU. And finally, we will see how a CPU works, central processing unit works. So what it does is the control unit fetches the instruction from main memory, that is from the primary memory. It fetches or gets the instruction from it. And what it does is, second thing it does is, control unit will decode the instruction and directs that the necessary data to be moved from memory to the arithmetic logic unit. So if you want to perform something, it will decode that instruction. Control unit will decode that instruction, and if some data is to be fetched from the main memory, the control unit directs it to send that data. I want this data, so send the data of these two elements. So it will be moved from memory to the arithmetic and logical unit. Then what it does is, first two steps together are called instruction time. So we call this as a instruction time or I time. So this is known as I time. So these two steps is known as I time. So fetching of instruction and decoding it, it is known as instruction time. And while decoding, it will, if we want more data from memory, it will also be fetched. Then after that third step, arithmetic and logical unit executes the arithmetic or logical operations. So whatever operations, whatever instructions we give, it will be executed by the arithmetic and logical instruction. ALU unit will execute it. Then after that, ALU stores the result of this operation in memory or in a register. So it might store simply in a temporary memory or register, or it will be storing in a primary memory. After that, it might be given to some output unit, or it might be stored in the secondary storage devices like your hard disk or anything. So after completion of this arithmetic logical unit, then step 3 and 4 together is known as a execution time. So we have CPU has instruction time and execution time, or E time. So we have CPU has two things, instruction time and execution time. So these two things are known as instruction time, and these two are known as execution time. Together we call it as a machine cycle. Combination of I time plus E time is called the machine cycle. That is the total machine cycle is this. So all these operations will be done in the CPU. So whenever it want to perform all these things, it has to do this. There is an instruction cycle and an execution cycle, and together we call it as a machine cycle. So these are the references from which I have taken. Thank you.